what we need to do for these problems, this first one, we're going to find our missing sides, given what we know. Now, anytime you come to a problem that has a right angle in it, you must think, can I use the Pythagorean theorem to solve this? If you look at number 1, the only angle that you're given is a 90-degree angle. So we need to go ahead and use the Pythagorean theorem to solve it. Once we solve it, we're going to write out our 6 trig functions with it. So we may be a little short on space, given the amount of space I gave myself. So we'll work to try to get that taken care of. 8 squared plus 15 squared equals, we're calling it y squared because that's the variable we have. All right, so that's 64 plus 525, I believe. Let's go ahead and plug it into our calculators. I'm going to grab mine. So 64, 225. Wow, I was way off. 64 plus 225 equals y squared. Add them together, then take the square root, and I get y equals 17. So I now know all my pieces to my triangle. So I can go ahead and write out my ratios for my trig functions. Now remember, there are 6 that we are working with. We've got sine, cosine, tangent, cosecant, secant, and cotangent. Now, if you don't have your notes out with what the values of the reciprocal functions are related to the regular ones, go ahead and pull that out. That's from that first video of secant, or from SOHCAHTOA, where I showed you guys that. So, important thing to notice, right here is our theta, which means this 15 is our opposite, 8 is our adjacent, and 17 is our hypotenuse. Now we had it y, but I'm going to relabel it, so then I have organized work. Sine is opposite over hypotenuse. 15 over 17. Done. Don't put it into a decimal, leave it as a fraction. These are ratios of sides. Ratios stay in fraction form. Cosine is 8 over 17. That's adjacent over hypotenuse. Tangent is opposite over adjacent. That is 15 over 8. Once again, keep it in a fraction. Cosecant is the reciprocal of sine. So we're just going to go, if I have enough room, 17 over 15. Secant is the reciprocal of cosine, which is 17 over 8. And cotangent is 8 over 15. Not too shabby, right? Okay. I want to see if you guys can figure this one out. See first, before you go through the whole problem, if you can do a relationship with one of our special triangles. So, I'm going to give you a couple seconds, maybe think of an idea. Make sure you have this written down, and then we'll come back in about 20 seconds, and I'll get started with this problem. Now, I just realized that this did not capture the top. So, there we go. Now the work's in there. My camera had it cut off a teeny bit. Okay, so looking at this, we have our theta. Opposite our theta is 4, and our hypotenuse is 8. 8 is 2 times 4. Is there any one of these that we can see that's related? Yes, we can. This 30, 60, 90 has the theta, which is x, and then 2 times that value. So we can actually relabel this to be a 30, 60, 90. And now without having to do the Pythagorean theorem, we can go ahead and say that this right here follows this pattern of x times root 3. X is 4, so this is 4 root 3. And now we're literally ready to write out our 6 values. Sine is opposite over hypotenuse. 4 over 8, which, yes, please reduce your fractions if possible. That is 1/2. Cosine is adjacent over hypotenuse. That is 4 root 3 over 8, which is just root 3 over 2. Tangent, I don't know why I was writing the whole thing out. We're going to leave it at tan theta. That's opposite over adjacent. So that's 4 over 4 root 3. Once you cancel this out, you get 1 over root 3. Now, we don't like having radicals in the denominator. If you guys remember back, if you can, back to where we worked with radicals, how do we get rid of it in the denominator? We rationalize. That means we're going to multiply the top and the bottom by root 3 over 3. That's going to go ahead and make this go away, and we're going to end up with root 3 over 3 as our tangent value. Now the nice thing, we've got the reciprocal functions coming up. So cosecant is 8 over 4, which is just 2. We're going to leave it like that. Secant, I'm running out of room, sorry, is the reciprocal of this right here, which we can just do the reciprocal of 2 over root 3. Which that is the same thing when we rationalize, because we don't want that square root in the denominator. That is 2 root 3 over 3, and we are finished with that. You cannot simplify it anymore. And then we have cotangent. Cotangent, if we look right here at the beginning before we rationalize, that's 4 over 4 root 3. If we flip it, that just gives us a square root of 3. And those are our terms. All right, I'm actually going to pause it, and we're going to move on to these problems in the next video to give you guys a teeny bit break if you need it.